Good morning, everybody. It's a pleasure being here. I'm Paolo Sabatini. I'm the co-founder and CEO of DMAT. I founded this company with MIT professor Admir Masic. We are participated by MIT and we license some of the rights of technology. So we focus on concrete. So we're working to change the concrete ecosystem. Why I say ecosystem? Because we all know that concrete is a fantastic material. It's simple, it's very effective, and is made of ingredients that are already distributed. So these enabling factors actually are the one that actually allow a huge global consumption. It's a $33 billion ton per year production. So take an elephant in weight, 5 billion of those. That's how much concrete is poured every year. It allows to build modern society, but create two biggest challenges. One very well known, 8% of global CO2 emission directly related to cement. And there are huge durability costs, $100 billion per year of repairing and maintenance cost due to corrosion. We are working to change the material by keeping enabling factors so that we can give a global answer to those problems. You might have heard about us. We actually published, after a few years of research led by MIT, a very successful paper on science where we understood why ancient Roman construction, so the Pantheon, everything that you see in Rome lasted for 2,000 years. By actually leveraging those understanding, we patent some chemistry, and in parallel of this research process, we understood how to use simple chemistry, simple mineral, to develop a material that is more efficient, lasts longer, it's more durable, and gives a lot of mechanical performance. We went to an industry-ready lab that works with Tunnel Maker, the hardest place where you can develop concretes, and we validate the technology in a production plant. So no retrofitting cost, you just add a mineral and you can get the most durable material. How to make concrete lasting longer? Those $100 billion costs per year are mainly due of cracks. Enemy number one, water infiltration, corrosion. You start losing pieces if you don't fix it by spending money. You actually end up in having structural problem. Our concrete, when it penetrates by water, completely seals, protect the rebar, and extend the durability. Second, our technology can provide a lot of mechanical performance. So by inserting our admixture, we can remove a lot of cement, meaning that we can provide a same exactly mechanical performance material with up of 20% less of CO2. We combine these two things, less CO2, more durability, with lower production cost at same performance that regular concrete. So that's how we want to innovate. We are not a premium cost, but we're a way actually to make a better concrete, more sustainable, that costs less. Together with me, there is a two team of executive. We have a group of fantastic advisors. MIT as a partner of the company, 4 global funds that already supported us. Today, we stand with working with more than 100 leads in the world in 10 countries. We just launched a partnership program for big players to qualify technology and deliver it to them. We did pilots pre-market, so it means like pre-certification, very successful. As I said, no retrofitting cost, super simple technology. Now we are working after having obtained European certification on a market precast production, so it's ongoing. There's going to be the first market project. And we are currently seeking ISTM certification. Always open, and we would love to partner with you to build new construction use cases, so new object, foundation, tunnel, regular building, whatever might help, and actually open up to new markets, Asia and Middle East. That's the future where we see concrete is going as well. Thank you.
Thank you, Paolo. So what is the price and gross profit? The margin comparing to traditional concrete?
Yeah, so the average building material margin, the market sits on 5% margin. Our goal actually is to double the margin for the producer, and in those increasing those margin by a cost-saving technology, we get our revenue out of that. So we have a technology for self-healing high protocol. People pay a premium for concrete to last longer. We cut the premium by half. Regular concrete, they see those small margin, we increase those margin.
Okay. And how, what's the strategy for reducing the carbon footprint associated with concrete?
Yeah, concrete is actually, it's a performance-based material. So engineering asks you a number, usually it's PSI, the basic number, and concrete producers source cements, water, sand, rocks, paper, and admixture to actually get the PSI. So we insert a new mineral admixture, the sum of the elements that you need to provide the same PSI goes up to 20% less. So it's 20% less in body carbon, and by expanding the durability of the infrastructure, we have also down the road saving in CO2.